a show that takes you back in time to learn about people you wouldn't really ever care about. And today we'll be exploring three brilliant minds: Albert Einstein, Guten Tag, John D. Cockcroft, hello, Governor, and Ernest Walton, a man of little words. All three men helped contribute to the atom. So without further ado, let's get started. Albert Einstein. I was born in the German city of Ulm, where I grew up a very proactive student and enjoyed my life there throughout my earlier years. It was until I worked in a Swiss patent office and taught at many universities that I did my most excellent work, but it mostly had to do with electrical currents and stuff like that, so I won't bore you with the details. Soon, after many years of teaching at universities, I traveled to America, where I taught at many universities lecturing about my many theories. It was in America where I was destined to stay because of, as we all know, the Nazis. In Germany, where I was born. Since my Jewish heritage prevented me from going back to Germany, I decided to stay in America for the rest of my days. Here I am, coming to America with fellow scientists and politicians. It was a very eventful day. It was in 1905 when I made my most excellent work, which was the theory of relativity. Now, as you all know, the theory of relativity is a tad bit too complex for sophomores, so I will try to explain it in its most simplest form. Now, please, don't get confused, and if you get lost, just look it up online. It's not that hard. It's called Google. So, here we go. Sorry about that, but we had to stop Albert Einstein for his explanation of the theory of relativity. It was far too complicated, so we just cut ahead to the most simplest explanation that he gives at the end of the video after his ranting. So, E vertical energy, as in the energy of a particle moving in a constant rate. So energy is equal to mass, which is obviously the mass of an object. Exactly what I just said. And the mass is multiplied by c squared, which is the speed of light squared, obviously, and that is the basic equation. Sorry, Einstein, but we're going to have to stop you there. You don't want to confuse our audience. But I thought our audience was more like, college professor types. Well, Einstein, you'd be surprised. Now let's go on to our next subject, who was born in the exotic and wondrous place where it's always hot and full of tropical trees. We are, of course, talking about London, England. So let's talk about John D. Cockcroft. So, take it away, John. Hello there, Governor. I was born in the city of Todmorden, United Kingdom, where I grew up a very proactive student doing many work there. It was soon after that I graduated from all my curriculum that I headed to the Cavendish Laboratory in Cambridge, where I worked on my most prized project with a couple more scientists who are clearly insignificant to my own genius, but that's just bragging there. Now I have to mention my most important fact here, that is, we're sorry there, John, but we have to cut you off. We have to talk about your partner in crime, Ernest Walton. But I didn't even mention my IQ of 1. I'm sorry, we have to move on. Ernest? Born in Ireland in 1903, but then, soon after my primary years, I moved to Cavendish Laboratory in Cambridge, where I met my partner, John D. Cockcroft. We're there. We both worked on our most prized possession at the exact same lab, which was the particle accelerator. Now, the particle accelerator was helped by Albert Einstein in one specific way, which was, hey, can I say it? No, John, stay out of this, but I want to say it. Fine then. To quote an article done by Stanford University, one very striking example of special relativity is observed kinematics of accelerating particles and particle accelerators. Einstein already predicted that accelerating electrons gain arbitrarily large kinetic energies as they approach the speed of light, which he argued they can never reach. Thus, once a particle's speed is close to c, its kinetic energy increases by its apparent increase of mass and not by a change in speed. So that is how Einstein's theory of relativity helped us make the particle accelerator. In the end, John and Ernest helped prove that you could split an atom at its nucleus using a particle accelerator, which was helped by Einstein's theory of relativity. And Einstein showed how energy could affect particles. Thank you, and that was this episode of Time